The fundamental purpose of a telescope is to gather light. There are two important ways of characterizing a telescope. One is in terms of the light gathering power, or how much radiation is gathered and then focused into an image. The light gathering power depends on the area of a telescope, and so goes up as the diameter or radius of a mirror squared. Thus, a telescope of twice the diameter has 4 times the light gathering power. A telescope of 3 times the diameter, 9 times the light gathering power. The other fundamental attribute of a telescope is resolution, or angular resolution. This is the ability of a telescope to discriminate fine details in the image of a distant object. The resolution is defined numerically in arcseconds as 250,000 times the wavelength of radiation being used divided by the aperture of the telescope. As long as the wavelength of the radiation and the aperture are in the right units, the answer will be in arcseconds. This scaling means that the larger the telescope, the smaller the resolution, or the finer detail that can be seen on a distant object. It also means that the shorter the wavelength of light, the higher the resolution, or the finer detail that can be seen on a distant object. Thus, optical astronomers want the largest possible telescopes and want to use the shortest possible waves of light to see fine detail. Magnification is not a fundamental attribute of a telescope, even though it's written on binoculars and small amateur telescopes. Magnification is not fundamental because blurring is of course also magnified when an image is formed, and when an image is magnified, the image is spread over a larger area of the detector. Resolution and light gathering power are the most fundamental attributes of a telescope.